Hello, Math 1093. This is Dr. P with The Polar Express. No copyright infringement intended. Anyway, this video is about how to quickly change from polar coordinates to rectangular coordinates and vice versa. So in this picture, I've drawn actually two pictures, one of which has a point whose coordinates are given in polar. So this is polar. And then another point whose coordinates are given in rectangular. And they're different points. These are meant to be just totally separate examples. And we're going to talk about how to go from polar to rectangular and from rectangular to polar, just as a way of summarizing what we learned in the previous video. All right, so first of all, suppose I'm given this point here, and its coordinates are r comma theta. All right, so again, what do those things mean? R represents, that first coordinate represents my distance from the origin, and theta represents my bearing as measured counterclockwise from the positive horizontal axis. That's what r and theta mean. And I know that the x and y coordinates at that point, that is the rectangular coordinates at that point, are x equals r times cosine theta and y equals r times sine theta. So if I wanted to write the rectangular coordinates at this point, those would be r cosine theta, r sine theta. And those would be the rectangular coordinates, just to be clear. Okay, by the way, there is one other way of seeing this besides using the fact that cosine theta is x over r and the sine of theta is y over r. And I just want to quickly talk about that because it's a nice little bit of geometry. You may remember that when we had a unit circle in the coordinate plane, like that, oh man, this is like the best circle I've ever drawn. A unit circle in the coordinate plane, and I had a point at direction theta. That point was cosine theta, sine theta by definition. That's actually what we define cosine of theta and sine of theta to be. They were the x and y coordinates you reach. If you start on the unit circle at this point, 1, 0, and travel counterclockwise theta units. Okay, so if you want the coordinates at this point, then what you do is you take those coordinates and you magnify by a factor of r. So magnifying, or actually let me just say dilating, cosine theta, sine theta by a factor of r in order to grow the radius from 1 to r gives new coordinates of r times cosine of theta, r times sine of theta, because I'm just multiplying both coordinates by r in order to grow the radius from 1 to r. Okay, so that's the idea behind why I have r cosine of theta, r sine of theta here. Any way you want to think about that is fine. Okay, now let's go over to this example. I have rectangular coordinates of x and y, and I want to figure out what my r is and what my theta is. Okay, this one's a little bit trickier. So my r is going to be the distance of this point from the origin. Now remember, I can always draw a right triangle showing my y coordinate here and my x coordinate here. Now notice I'm marking that as x even though x in this picture is negative. I'm just going to allow this side to have a signed length of negative something if that length is over here, and positive if that length is over here. Similarly, y will be positive if the point's above the horizontal axis and negative if below. Okay, anyway, so my radius is going to be this distance here, the distance from the origin, and I know that r squared has to equal x squared plus y squared by the Pythagorean theorem. So I know that r will be equal to the square root of x squared plus y squared. And in the last video, we talked a little bit about how that can be positive or negative. And actually, we can use a positive or negative number as the r coordinates. But conventionally, I'm going to tend to use the positive value because it is always possible to do that. And if I want to use the negative value, I have to think about walking backwards once I've turned myself in the right direction. So I'll almost always take the non-negative square root. That may be 0 if I'm at the origin, but usually be positive. Okay, so that's my r. And then what about theta? Now remember, theta is the angle from the positive horizontal axis to this ray here. And one thing I know about that is that the tangent of theta is equal to y over x. And that does not necessarily mean that theta is the inverse tangent of y over x. Although one thing we can say is that theta will be equal to either that, which will always give me an angle in the first or fourth quadrant, just by definition of inverse tangent, That's what we take to be the definition or the range for inverse tangent is from negative pi over 2 to pi over 2. Or we can say that theta is equal to the inverse tangent of y over x plus a half rotation, that is plus pi. This is assuming that Assuming that theta is not pi over 2 or negative pi over 2. In other words, assuming that x is not 0. If x is 0, then we have a problem just because this expression here is undefined. So we'll never be able to calculate that because it's undefined. But then again, if x is 0, then I'm somewhere along this axis, which means my direction is either going to be pi over 2 or negative pi over 2, or if you like, 3 pi over 2. By the way, there's a lot of ways of representing the same point in polar coordinates because you can always add a full rotation to whatever your theta is. Okay, anyway, so there's my r. This is my r. And one of these is going to be my theta. In this particular example, I think it's going to be this one because the inverse tangent would only give me an angle between here and here. In fact, it would give me the one down here. And I would have to add a half rotation in order to get the correct one. All right, so my polar coordinates for this point are going to be, they're going to be square root of x squared plus y squared, and then the appropriate theta. I'm just going to put theta there and point you to this little bit of problem solving that we have to do here. All right, so now let's give these things a test drive by doing a couple of examples. See if we can get these done fairly quickly. Okay, so first of all, suppose I'm given the polar coordinates. So I'm just going to make a table here, polar coordinates and rectangular coordinates. And see if I can convert quickly from one to the other. All right, so first of all, let's suppose I'm given the coordinates of, let's say 4, 3 pi over 4. And I want to change these to rectangular. Okay, if I'm given r equals 4 and theta equals 3 pi over 4, that's an angle in the second quadrant. It's like directly northwest, if you like thinking of it that way. I can use my formulas. X equals r cosine of theta. So I get 4 times cosine of 3 pi over 4. Cosine of 3 pi over 4 is, what is that? That's negative 1 over root 2. So that's negative 4 over root 2, which I can change into this. That's negative 2 root 2. All right, I need a little more room here. All right, what about my y? Y is going to be r times sine theta, which is going to be 4 times the sine of 3 pi over 4, which is 4 times 1 over root 2. I guess maybe it would have been easier if I just multiplied by root 2 over 2 like everybody else does. Maybe I should just do that now. I don't know why I thought 1 over root 2 would be better. So I get 4 root 2 over 2, which is 2 root 2. So those are my coordinates, negative 2 root 2. There we go. And then positive 2 root 2. It's kind of awkward to say out loud. Okay, now let's suppose I have rectangular coordinates of, I'm going to make up something kind of nice this time. In the last video I used ones that were sort of random and weird. Let's do 8 root 3 comma negative 8. All right. So this time I'm given my x and my y, and I need r and theta. Okay, now remember, r is equal to the square root of x squared plus y squared. In this case, that is the square root of 8 root 3 squared plus negative 8 squared. 8 root 3 squared is like 64 times 3. Regretting this already. Negative 8 squared is 64. Actually, that's kind of nice, though, because I can distribute that and get 64 times 4. And that is, well, the square root of 64 times the square root of 4. That's 8 times 2, which is 16. Huzzah! All right, so my r is 16, but what is my theta? Well, my theta, let's see, is there some easy way to figure this out? Let's use the fact that the tangent of theta is equal to negative 8 over 8 root 3. That's my y over x. So that's negative 1 over root 3. Now, you may recognize that negative 1 over root 3, this is the tangent of negative pi over 6. It is also the tangent of 5 pi over 6. And now we have to use our noggins to figure out which of those is correct. Notice that those are exactly half of a rotation off of each other. But this set of coordinates here, this describes a point in the fourth quadrant because my x is positive and my y is negative. So I'm over on this direction from the origin. So I believe that negative pi over 6 is going to be the correct angle. That's one in the fourth quadrant. Okay, I could also call this, if I wanted to, 16 comma 11 pi over 6. I could just add a full rotation to that. I could also, for that matter, call it 5 pi over 6 and then use a negative 16 here. So I'm going out in the, let me illustrate that. So negative 5 pi over 6 is in this direction, but I march out negative 16 units, which means I'm still going in the right direction over here. Okay, I'm just mentioning this because I want you to see that there are a number of ways to write a point in polar coordinates. There's really just one way to write a point in rectangular coordinates. Okay, so anyway, that's it for this video. The point was to systematize a little bit more how we convert between polar and rectangular coordinates, and I think we've done that now.